Everything in the universe is made of atoms. They are the building blocks of the universe. Trees, birds, animals, even humans, air, water, metal, gold, diamond, iron are made of atoms. Atoms are so small that millions of atoms would fit on the head of a pin. In an atom, protons and neutrons are easy to locate because they are found at the center of an atom, which is called the nucleus. Since electrons are not found in the nucleus, then where can these negatively charged very small moving particles whose mass is almost 1,000 times smaller than the mass of a proton be found? Electrons spin around outside of the nucleus in spaces that are called energy levels or shells. Although these electrons all have the same charge and the same mass, each electron in an atom has a different amount of energy. Electrons are arranged in different energy levels or shells around the nucleus of an atom. Each shell has one or more subshells within it. There are 4 different types of subshells like S, P, D, and F. Each subshell has one or more orbitals within it. Each orbital holds a maximum of 2 electrons. The first energy level can hold up to a maximum of 2 electrons, the second energy level can hold up to a maximum of 8 electrons, the third energy level or shell can hold up to a maximum of 18 electrons, the fourth energy level can hold up to a maximum of 32 electrons, and so on. But this is not so simple as it looks. The first energy level has one subshell S, and one orbital which can hold up to 2 electrons. The second energy level has 2 subshells S and P. S has 1 orbital and P has 3 orbitals. Total they can hold up to 8 electrons. The third energy level has 3 subshells S, P, D. S has 1 orbital, P has 3 orbitals and D has 5 orbitals. Together they can hold up to 18 electrons. The fourth energy level has 4 subshells S, P, D, and F. S has 1 orbital, P has 3 orbitals. D has 5 orbitals and F has 7 orbitals. Together they can hold up to 32 electrons. Electrons with the lowest energy are found closest to the nucleus, and electrons with the highest energy are found further away from the nucleus. For example, the S subshell has lower energy than the P subshell. The electrons in the shells close to the nucleus have a strong force of attraction to the center, and the electrons in an atom's outermost shells do not have a strong force of attraction to the center. The electrons in the shell close to the nucleus bounded tightly. For example, the first shell is bounded tightly compared to the electrons present in the second, third, and fourth shells. Electrons play an important role in various fields of science such as electricity, magnetism, chemistry, etc. Electron configuration is the arrangement of electrons in different energy levels around an atomic nucleus. The periodic table is made up of horizontal rows or periods and vertical groups. In this picture, the periodic table has been labeled in blocks or subshells. The elements can be classified into 4 blocks or orbitals such as S, P, D, and F. In the first period there is the 1s sublevel. In the second period there are the 2s and 2p sublevel. The third period is similar to the second period. There are the 3s and 3p sublevels. Notice that the 3d sublevel, which belongs to the third energy level, does not actually fill until after the 4s sublevel is filled. In other words, the 3d sublevel fills during the fourth period. When the third level contains 8 electrons, the first 2 electrons go into the 3s, then the 6 electrons go into the 3p. The next 2 electrons go into the 4s, instead of going to the 3d first. In the fourth period there are the 4s, 3d, and 4p sublevel. Also notice that, for the d block, the number or the coefficient in front of the d is 1 less than the row it is in. For example, 4s, 3d, and 4p. The fifth period is similar to the fourth. In the fifth period there are the 5s, 4d, and 5p sublevel. The 4f sublevel fills during the sixth period. After the 6s sublevel fills, the 4f sublevel fills with its 14 electrons. This is followed by the 5d and 6p sublevel. Notice that for the F block or sublevel the number in front of the F is always 2 less than the row it is in. For example, 6s for F, 5d and 6p. The seventh period is similar to the sixth period. There is the 7s, 5f, 6d and 7p sublevels. One thing to remember that the fourth period in the periodic table does not represent the fourth energy level. In the fourth period there is the 4s, 3d, and 4p sublevel. This does not include other fourth energy sublevels like 4d and 4f, and it also includes the 3d subshell, which is in the third energy level. There is also a diagonal rule, and it has a diagram that is easy to remember, and that allows us to easily figure out the order in which electron orbitals are filled. In order to use the diagonal rule we must follow the arrows from tail to tip, starting with the 1s, the first arrow in the upper left-hand corner, and moving down through the arrows to the lower right-hand corner of the diagram. Beryllium is the fourth element on the periodic table, and the atomic number of beryllium is 4. That means the number of electrons in beryllium is 4. For beryllium the first 2 electrons will go into the 1s orbital. Since 1s can hold 2 electrons, the remaining 2 electrons will go into the 2s orbital. Therefore the beryllium electrons configuration will be 1s2, 2s2. Oxygen is the 8th element on the periodic table, and the atomic number of the oxygen atom is 8. That means the number of electrons in oxygen is 8. We know that s orbital can hold 2 electrons. Since 1s can hold 2 electrons, the next 2 electrons will go into the 2s orbital. The remaining 4 electrons will go into the 2p orbital. Therefore the oxygen electron configuration will be 1s2, 2s2, 2p4. If we want to write the electron configuration using the periodic table, first we have to identify the element we want to choose on the periodic table and mark it. Then we have to locate hydrogen as our starting point. Then glide across each row, left to right and top to bottom until we get to our marked element. Therefore the beryllium electrons configuration will be 1s2, 2s2. We have to identify the element we want to choose on the periodic table and mark it. Then we have to locate hydrogen as our starting point. Then glide across each row, left to right and top to bottom until we get to our marked element. Therefore the oxygen electron configuration will be 1s2, 2s2, 2p4.
Thank you for watching. Don't forget to subscribe, like, and share this video.